This video demos problem 4 from chapter 14. In that problem, we're given a set of information about a bond. It has an annual coupon rate of 6.89%, a par value of $1,000, a current price of $895.22, and 9 years remaining until maturity. Again, your problem will have different values. We are asked 3 questions about this bond. First, what is its current yield? You can calculate this using a regular calculator. The current yield is simply the annual interest payment in dollars divided by the current price of the bond. The annual interest payment, I'll actually work it separately. I'll just start a little section down here. So we want the answer in dollars. The annual interest payment is calculated by taking that coupon rate, 6.89%, and multiplying it by the par value of $1,000. So our annual interest payment is $68.90. To find the current yield, take that $68.95 and divide it by the current price of $895.22. This is typically expressed as a rate, so the current yield is 7.7%. The second question we're asked is to calculate the approximate, that shouldn't say approximately, but the approximate yield to maturity. So what they're basically asking us is, if we, well, let me restate that. If we were to buy the bond at the par value of $1,000 and receive coupons of $68.90 every year for 9 years, and then receive the par value at maturity, that would give us a yield to maturity of 6.89% every year. However, we can buy the bond for less than $1,000. It only cost $895.22. So because we can buy it for less, but we're getting $68.90 a year, that means we're going to earn a rate that's higher than our coupon rate. Our yield to maturity will be something higher than 6.89%. It's actually really easy to solve for the yield to maturity using a financial calculator, but for many years people used this approximate yield to maturity equation because they didn't have financial calculators. And for whatever reason, the homework website wants you to use this approximation formula, which I actually think is harder than using a financial calculator. But let's plug away at it. It's not too bad. It's just a matter of getting your parentheses in the right place. So we want to calculate the numerator, which is our annual interest payment of $68.90, plus we want to take our par value, and I'm just going to type in the values instead of creating links, I think. The par value is $1,000, subtract the current price of $895.22, divide that by 9, which is the current years to maturity, and I'm actually going to put another set of parentheses around here because what I want it to do is take the par value, subtract the current value, then divide that by 9. And now and you can see Excel color codes. I don't know if you can actually see that on the video, but Excel color codes my parentheses to tell me if I've closed them properly. And I've closed the purple ones, and I've closed the green ones, which is making purple now, but I've not yet closed this black one. So I'm going to add an extra parentheses to close that black one, which is essentially the entire numerator of the large equation. And then I want to divide all that by the par value of $1,000 plus the current price. Actually, I'm going to put one more parentheses because I want the par value of $1,000 plus the current price of $895.22. Close that parentheses, then divide that by 2, close that parentheses. That will give me the numerator of the entire large equation, and that gives me the approximate yield to maturity, which is a percentage. So what we want to do is make certain that this answer is higher than the coupon rate, which it is. And again, the approximate yield to maturity should be higher than the coupon rate because we can buy the bond for less than par. If the current price had been higher than par, then the approximate yield to maturity should have been lower than the coupon rate. Now, the third part of the question says, well, let's find the yield to maturity using a financial calculator rather than the approximation formula. So I need to keep in mind the current price of the 895.22, 9 years to maturity, and that coupon rate of 6.89%. I'm going to pop over to the time value of money calculator. What we're going to be solving for is the rate. We input as the present value the current price of $895.22. The payment is actually your dollar annual interest payment, which we calculated in Excel as the 68.9. So input your payment is 68.9. The future value is your par of 1,000, and the number of time periods is your 9 years to maturity. Now, whenever you solve for a rate, you have to have a sign change among these three variables, the $3 amounts. What you need to do is assign the values that are going the same direction the same sign. Well, basically what would happen is you would pay $895.22 for this bond, so it would be an outflow to you if you were to buy it, and you would receive interest payments of $68.90 every year for 9 years, and at the end of the 9th year you'd receive $1,000 as a future value. So the payment and the future value are going the same direction. They are being received by you. The present value would be going the opposite direction. It's a amount you would pay. Since we're paying it, I'm going to make it negative, and I'm leaving the payment and future value positive. I think a lot of people mistakenly think the payment should be a negative number because it's a payment, and they just view the word payment as meaning an outflow. But that's not what payment really means. It means an annuity. It's a payment that could be coming to you or being taken from you. In this case, it's coming to you, so I'm making it positive. So I've grouped the dollar amounts going the same direction with the same sign. The two inflows are positive, the one outflow is negative. Now I just press rate, and there is my actual yield to maturity, 8.61, whereas the approximate yield to maturity, which was incorrect but close, was 8.5.